Hi, everyone. This is our continuation on the counting techniques. This time we'll be talking about what's called combinations. Last time we talked about permutations. Every time you hear the word permutation, then you need to remind yourself that the order of when you pick the items, the order matters. Now, when you do combination, the order does not matter. So if you remember the last example, one of the examples we did last time, we had, let's say, 9 people, and we wanted to choose the president, vice president, and secretary. Of course, this implies that the order matters. But if I tell you now, I have 9 people, I would like to pick 3 people for a committee, or 3 people to go for a conference or something. It doesn't matter which one you say first, right? So in this time, we'll be talking about combinations. So when you finish this, you will learn how to solve problems using combinations. And what is a combination is nothing but a distinct group or set of objects without regard of their arrangement. So we don't care about the order. So the number of combinations possible when R objects are selected from N objects is found by the combination formula. I'm going to give you the formula in a second, but here, keep close attention to the word combination and choose the N objects. So again, remember when we have N objects, suppose that you have N objects. This is the first object, the second object, the third object, and the fourth object, and so forth. So if you have N objects, and your job is to select R objects from those N objects, and the selection, which one you're going to pick first does not matter, then you have a combination. Last time we talked about NPR when we did permutation. This time we're going to be talking about NCR. As you can see, P for permutation and C for combination. So here's the formula. You put your N factorial, whatever that number is, the original number of objects, the total number of distinct objects, and R is how many of those objects you are going to choose. Sometimes they call this N choose R. And so mathematicians, they use this terminology, N choose R. So let's do an example. In your American history class, you are assigned to read 3 books from a list of 8 books. So again, N is 8, so that's the total number of objects. Here we have books. And you are required to read 3. It does not tell you which book should be read first, right? The job is just read 3 books. In how many ways you can select your 3 books from those 8 books? Well, again, by reading this exercise, there is no implication, or there is nothing that suggests that I need to pick this book first and then that book first and so forth. So this is a combination problem. It's going to be, like I said, N is 8 and R is 3 is going to be 8C3. So again, if you look at the formula, let me remind you of the formula. NCR is N factorial divided by N minus R factorial times R factorial. This here, N is 8, so that's why I put 8 factorial. R is 3. Now 8 minus 3 becomes 5 factorial times 3 factorial. And then after that, you do the calculation. I'm going to post a video on how to compute this without doing it this way, but this way is just fine also, right? So you have 56 different choices, right? So you have 56 different ways to choose your 3 books among 8 books. So I was saying again that I'll show you how to do this in a calculator directly. Just the major step is to decide your N and R and to decide whether you have a permutation problem or a combination problem. Once you set those up, then it's just a matter of formula, or you can put this in a calculator. Well, here's another example. Jan has 10 different photos from which she will choose 6 to hang on a wall. In how many ways can she do that? Right, as you can see here, well, N is 10, you have 10 different photos, right? Well, she are going to choose 6 to put on a wall. The exercise does not specify, well, the order in which to put that. So it's going to be a 10C6. So here's your N, here's your R. It's going to be 10C6, and it's going to be 10 factorial divided by 10 minus 6 factorial times 6 factorial. and 10 minus 6 is 4 factorial. And if you write things down, right, well, you have 9 and 3. 9 divided by 3 is 3. And if you put in the calculator, you get 210 different ways. So Jan has 210 different choices to choose the 6 pictures to hang on the wall. At the end of the day, she will do just one of those 210 choices, right? She's not going to just, right, just try all of them. She's going to just sit down and say, okay, which ones she likes and so forth. And she will end up with having one possibility among those 210 possibilities. Well, here's an exercise that is a little bit more complicated. But if you really look at it slowly, it's not that bad. Suppose at a cafe, Chinese restaurant, in every word problem, it will try to not trick you, but there's some fluff information that you should not pay attention to. So this exercise is talking about an Oriental cafe, Chinese restaurant. What happens if it was a French restaurant? Is it going to matter? No, of course not. Anyways, in this restaurant, dinner consists of selecting 3 items from column A. So then in their menu, they have column A, column B, and column C. So you need to select 3 items from column A, 4 items from column B, and 3 items from column C. In columns A, B, C, we have 5, 7, and 6 items respectively. It means that A, you have 5 different choices, B, you have 7 different choices, and C, you have 6 different choices. In how many different ways, or in how many different dinner combinations are possible, or how many combinations are possible? Well, if you make a small drawing here, suppose this is my task, my big task. I need to pick my 3 items from column A, and then I need to pick 4 items, 1, 2, 3, 4 items from column B, and then I'm going to pick 3 from C. So this is from column A, this is from column B, and from C. Let's focus on column A. How many choices and how many ways you can do this? Well, A has 5 different choices. So I'm going to choose 3 from 5. So it's going to be 5C3. So this number will give me how many different ways to pick my 3 items from column A. Well, I'll do the same thing from column B. It's going to be what? 7, choose 4. That's from column B. So this is for A, this is B. And then the last one, I'm going to have 6C3. That's the number of how many possibilities I have when I'm picking my 3 items from column C. Well, now, in how many ways you can do the whole dinner? Well, you just multiply these things together using what's called the fundamental principle of counting that we discussed before, right? So that's what it is really. So column A, 3 of 5. Column B, we're going to pick 4 out of 7. Column C is 3 out of 6. So we are going to have how many dinner choices I have. C or 5C3, that's how many possibilities from column A. 7C4, how many possibilities from column B. And 6C3, how many choices from column C. And you multiply them all together. If you do the math, if you do the calculation, and you compute this separately, you find out that this is 10, and this is 35, and this is 20, and therefore you have 7,000 different ways to have dinner in this restaurant. A lot. Yeah. Well, I hope that this gives you, or this gave you an idea how to do combinations. Remember, permutations when the order matters. Combinations when the order does not matter. The counting techniques can be a lot more complicated, but for this course we are going to stop here. If this is of interest to you, you can always pick a higher math class, and usually the discrete mathematics classes are the ones where you find those type of mathematics to learn. So that's why the major going to computer science and mathematics, they will have to deal with a lot more complicated situations than the one we just covered. So now you can go and start doing your homework.